Good morning. So my name is Jack Ryan, and I'm a senior at North Central College. So I'm pursuing dual degrees in math and theater with a minor in computer science, and I'm part of our College Scholars Honors Program at North Central. I'm also a member of our math club, Blue Key National Honor Society, and our theater department. So this morning I'll be talking a bit about the research I'm doing to complete my undergraduate thesis, with a special emphasis on the impact that the liberal arts education has had on my ability to conduct this scholarly research, as well as the impact on my learning and future career. So to give you a bit of a background on my research project, the title is called Betting Better on Broadway: The Application of Statistical Matrix Theory to the Prediction of Tony Awards for Best Play and Best Musical. So this project is completed as my undergraduate thesis, which is completed in partial fulfillment of the requirements for the College Scholars Program, which is our honors program on campus. So we aim to analyze what previous scholarship has done is given us statistical principles and methods to rank sports teams based on the number of wins and losses and the margin by which one team particularly wins. So Kali and Massey are two practitioners who suggest two such methods, which uses those wins and losses and or margin of victory as inputs into these algorithms. So they yield a definitive ranking of the sports teams based on these input values. So our research project is interested in applying these methods to theatrical productions in an attempt to rank works of theater using quantitative values. So the quantifiers we're using in this project include the weekly percentage of seats sold, the weekly number of seats sold, the weekly average ticket cost, the weekly top ticket cost, and then finally the weekly gross profit of the show. So Tony Award nominees from the past 10 years were ranked using these methods, and the quantifier method combination, which yielded the most promising prediction, are determined. And then these method quantifier combinations are going to be used in the near future to predict the Tony Award winners for Best Play and Best Musical for the 2015-16 season. So it adds to this conversation by employing methods that are previously used to analyze sports teams to quantitatively analyze art, which can be challenging and isn't always done. They've only usually been used to rank sports teams. So it also yields an interesting discussion as to whether the Tony Awards reflect the commercial success of a piece of theater or rather its artistic merit. So our methodology included gaining an understanding of the current processes of Tony Award selection. That way we could uncover potential biases. And then we looked at collecting and organizing the data from the Tony nominees from the past 10 years, running these algorithms on our data sets and determining which quantifiers or combination of quantifiers is the best predictor of Tony Award success, and then using these as a basis to predict the 2016 awards. So I'm going to talk a bit more about our specific results towards the end, but sort of shift and talk about resources and mentoring that led to the formulation of the project. So I've been a bit nervous about selecting a topic for the undergraduate thesis since freshman year because it seems like such a large project and really reflects the culmination of your undergraduate coursework. I was assured by my older colleagues that you'll get an idea and it'll come to you, but I wasn't sure. But sure enough, as a result of the intimate class sizes and personal mentoring that happens at North Central, I was able to find a topic that excited me and inspired me to begin working. So the basis came during the spring of my sophomore year in linear algebra class when we were doing a project about these Kali and Massey methods. We basically took a fake season where my professor had formulated scores and used both methods to rank these different sports teams. So I really enjoyed this project and her course in general and went into her office to chat with her about potential ways of expanding this. So we tossed around ideas such as using it on reality TV shows such as The Bachelor or The Bachelorette. But I ultimately decided at that point that I wanted to use it on critical reviews of musicals and plays in an attempt to merge my interests in theater and math. So that sort of evolved over time, but the project transitioned into the research questions, which I previously presented. But I'm trying to say that it would not have been possible without the close mentoring of my advisor and professor. And because of these small classes, which are standard in the liberal arts environment, it created a classroom setting which was able to cultivate this type of learning process. So we had the ability to cover these topics, such as the Kali and Massey methods, which might not normally be covered in an undergraduate linear algebra course, just because of the subject matter. The limited number of students also permitted me to have the ability to actually talk to my professor individually about the project and its potential applications, and that allowed it to grow from a simple question into an entire research project. So my ability to pursue not only this research project, but other scholarly research is a direct result of the access to faculty, mentoring, and small class sizes. It's also had a significant impact on my learning. So it required me to learn the discipline required to pursue an individual research project. So instead of being told what questions to answer, I have the freedom and then also the challenge of choosing my own questions. It's in distinct contrast to most undergraduate coursework where you are laid out with the questions and told to answer those. And it certainly seems to be a shift towards the kind of coursework I'll encounter at the graduate school level. I've learned how to ask questions of myself and be self-critical of my work while also having the confidence in my research methodologies to know that I'm pursuing this project in the way that would yield definitive results. So I'm also faced with being the expert in the subject material. So while my thesis advisor, Dr. Catherine Heller, is an invaluable resource to me, and I'm tremendously grateful for her, she doesn't always have the answers like she would if she were teaching the course. So in this way, I've learned to be confident in my methodologies and learn how to defend my claims and their validity. I've also learned how to stay motivated to work on this long-term research project, which at times you don't have any interest in working on. So as opposed to undergraduate coursework, we're told when particular homework assignments are due, but the thesis, we're simply told a rough draft is due on this date and a final draft on the other date, and you're sort of left to complete the project on your own time. So it's beneficial because it promotes flexibility and is definitely more of a shift towards that higher level of learning, but it also can be challenging because the motivation has to be completely intrinsic. So all in all, while the completion of the undergraduate thesis certainly poses challenges, the rewards, I think, outweigh the drawbacks exponentially. And there's much I've learned both about the subject material and as well as general research methodologies and time management and writing skills. Having the opportunity to conduct this research project will have tremendous implications for my future career. I'm currently planning on pursuing graduate work in math to obtain my PhD and then be a college professor. So this project, along with other summer research projects I've done at other institutions, have not only strengthened my confidence in my ability to pursue individual research projects, but has also helped to model the type of interactions I would like to have with future students. So in addition to pursuing my own research agenda in the field of pure mathematics, I hope to cultivate a love for mathematical research in my students and to help hone their research skills. So my career goals stem from a deep desire to both extend the community of next generation mathematicians and also introduce them to the fun of math research for those who might not have tried it. So having the opportunity to work with such talented professors, advisors, and mentors, I hope to be able to mirror the manner in which they approach research with undergraduates, which I hope will ultimately make me a more successful research mentor at that point. So my future career will be impacted by this research project, not only by the physical acquisition of new knowledge, but also in the way that I'm able to observe best practices in supervising research. So in terms of our results, we're still in the process of this. We're not done until May when the thesis is due. So we're still in the process of collecting and analyzing results, but our preliminary findings indicate a stronger ability of the methods to predict play success compared to musicals, which is fairly interesting, and I'm sort of trying to think through why that might be. But at this point, we have a general idea of the quantifiers, which continuously seem to be the best predictors, and our methods are in the process of being changed and analyzed so that we can get stronger results, and then we can make the most accurate prediction for that 2015-16 season. I'm excited, though, about our prospects for accurately predicting the series winners, and I just want to thank everyone for being here this morning.